All right, fresh meat, get going. Okay. Mmm. Mmm. Ashton, sit down. Do your daily quiz. Trey, you're a horrible liar. Remove head from rectum. Return food. I think it's out in the cabin, along with your detention. Oh, hey, look, we found it. Come on, don't be stealing food, you goblin. Come on now. Again, make sure that you are labeling these. Hi. Yeah, you were. Yeah, the lesson. You had 4 days. Then you just say that. Abby, if you haven't done the thing, don't do the daily quiz. Just chill. Do it when you're ready. You're not ready, don't do it. Yeah? Well, you're finding a solution, right? Clipboard, good. Middle of my lane, not good. Thank you. Are you done with your daily quiz? Make sure you're labeling these. Make sure it says 2-7 proportions, daily quiz. We're also halfway through the semester. You're supposed to be scoring these yourself. When I go through the notebooks, the binders, whatever you got your stuff in, and we hit page after page after page where a kid has not graded them at all, have not scored them, I'm just going to move on. Okay? You take part in it. This is just a daily gut check. Do I get what was going on last time? Hey, even if you're not sure, try something. Got a bunch of fraction bars there. What does that mean? What operation is that? How do I undo that? Give you about a minute to finish up. These should be relatively quick. For those of you who are in Spanish, I gotta ask, does she just play a movie in every class?
Basically.
Or video?
No.
No?
Today we did like, we finished one, we just like worked on paper and stuff.
Okay. Just
Sometimes
curious.
we play like background music done over.
Well, that's fine. Just always seems to have something going on. Alrighty. Now you got options. Option 1 is cross multiply, then divide. Like that. Option 2, which most of you seem to prefer, was Jesus fish. Multiply the two that line up, divide by the one that doesn't. Okay, you make an alpha out of it. Which is exactly what we did, right? We multiplied these two and then we divided by 51. That's why that loop works. Because you're multiplying and then dividing to isolate your variable. Where it gets kind of hairy is when you got more stuff than just a number. When I cross multiply, I need to distribute. When I cross multiply, I need to distribute. Now, are you okay with me going straight there, or do we need to actually show the distribution? Okay. See a couple of squinting faces. So I'm going to show it. That's 5 times x plus 5. That's negative 15 times x minus 7. Okay. So I get here, and then it's an equation like any other that we've been dealing with. I don't care what you hit, just hit something. I don't care what you move, just move something. You can screw up, just screw up going 100 miles an hour. Probably not a good thing to tell a room full of freshmen who are about to get their licenses. So, you'd say, Haven, 2 questions. A, are the Fruit Loop Pop-Tarts even worth it?
They're so good.
Are they? It's the first time I've ever seen them. I saw you were eating them. What's the verdict? Yay, meh, whoa, gross.
They're good for about 2 bites.
After that, is what the hell am I eating?
Well, let's hope they were better than those
Okay.
donut burgers that we had for lunch.
Wait, that was an actual thing?
Yeah. Dude, that was
A kid came in with it, and I thought that he just made it himself from crap in the lunch line.
As long as you didn't put
That was the lunch?
Yeah.
Yeah.
Glazed donut burger.
So weird. Without ketchup and pickles, it was fine. But a burger makes like
I mean, I would understand if it was like glazed donut sausage patty, because then you kind of got that breakfast theme going on, but...
I think there is sausage. It looked like sausage.
Huh. Okay, so anyway, question number 2. Which of those 4 do you want to move? Okay. It's a positive 5x, so I will subtract 5x. Show me that it zeroes out. I've got 25 is negative 20x plus 105. And then we say, who's lonely? And then the kid who's not original says, hit me. I'm going to subtract 105 from both sides. Show it zeroes out. And get my... What color do we... What color are we going to next? How about red? We'll do red. Get a negative 80 is a negative 20x. Divide both sides by that negative 20. X is also 4. So, this one, I'm going to give, you know what, I'm just going to go a straight right or wrong. Because, Jesus fish, you can just one-shot that, right? How many of you, like those ones, if you saw it on an assignment, when you saw this up here, you're like, okay, done. That's good. I want that. Over here, did you distribute correctly? I'm going to say 2 more for the work steps and then 1 for the answer. Because somewhere along the way, well, that was still a multi-step equation. That was still variables on both sides. There was a lot of places something could have gone wrong. You say that so, like, worried. Yes. Triangles. Fear me. It's fine. Okay. Any questions here? Yep.
I did this like super weird. And it didn't work out.
That's a statement, not a question.
I know I did wrong.
It didn't work out, but not for the reason that you think. All right. Coming all the way back to the beginning of this, Ashton tried something. It didn't work, but it was actually a good idea.
That's fine.
Proportional reasoning doesn't have to be formulaic. How did I get from 5 to negative 15? What did you do to go from 5 to negative 15? What do you multiply by? Meh? Negative 3? So, if I multiply by negative 3, couldn't I have taken this times a negative 3? Adding 3x, adding 7. Like, would that work? If I multiplied this by negative 3, oh wait, I didn't multiply this by negative 3, I multiplied that by negative 3. And that's where you went wrong. To get from the 5 to the negative 15, you multiply by negative 3, multiply this side by negative 3. Add 3x, subtract 5, divide. You could have still done that. You just worked with the wrong one. Okay? If you had done that instead, I'm totally cool with it. Because you're still displaying that proportional reasoning. Yo!
How did you check that second?
Oh, if I say that 4, well, first of all, that wasn't included in the points because I didn't say solve and check, where you have to check it. But if you're going to check it, you said that x was 4, right? So shove a 4 in there. What's 4 minus 7? I'm going to go 3. 4 plus 5 is 9. Now check your cross products. 45 equals 45. Or reduce it, and they both come out to negative 3/5. Okay? So you can check them, same as always. Plug it in. Make sure it's a true statement. You're heading down the right spot. You just multiplied the wrong side. So I'll say...
Dang, I can multiply it all. That's how I got confused.
5 minus 3 minus 3 is 5 negative 2. 5 plus 5. Oh, and then you missed a negative there.
Where?
3 out of 5. Right there. Okay. It's been 4 days. No one's asked.
No one.
We had some folks come in on Spartan Time on Friday to ask about the proportion and ratio stuff. A little more practice with that, but not with this. Speak now or forever hold your pieces. You better have the problem written down because I ain't logging in through Clever. It's annoying.
It was 40 and it was like 15 something out of 45, but it was like 2 hours instead of minutes, and we were just supposed to like times that by 6, right? So what do you want us to do?
I would tell you if I know what you were saying.
For number 40, it was like a story called, I think. They had like hours, but the other one was minutes.
You cannot compare things unless they're in the same unit of time, yes. If I want to know how long it takes you to, say you start working at, Domino's. How long does it take you to make pizza versus how long does it make this person make pizza? Well, what if they're just really good and they can just splat, slap, slide it down 45 seconds? Whereas you're over here like, wait. and it takes you 3 minutes. I don't want to compare seconds to minutes, right? I would turn either the 45 seconds into 3/4 of a minute, or I would turn the 3 minutes into the 180 seconds. That is correct. You do want those in the same. Otherwise, you can't compare them. Kind of like we were doing that with the unit conversion stuff, right? Who's faster? Well, if this person runs a 40-yard dash in this long, and this person is running a 100-meter sprint in this long, I can't compare those until they're the same unit. So, yep, that's a good question. Okay. Before I go into today's should be easy because it's just a continuation of 2-7. It's more about some notation than anything else. Before we get into it, though, a couple of things you got to be aware of. Thursday will be quiz number 4. Okay. So we do 5 days of in-class instruction, review quiz. 5 days of in-class instruction, review quiz. We've had a couple of interruptions in there, but it basically comes out to about every 2.5 weeks, we get a quiz, which is why we hit the end of the quarter, and that was our 9-week period. That's why there were only 3 quizzes for the quarter. When we hit 4th quiz now, if you don't have stuff in from weeks 1 and 2, from the quiz 1 stuff, the quiz 2 stuff, if you don't have that stuff in by now, y'all, it's been a month and a half. You had enough time. Okay? Now those are just perma zeros. I would much rather that you stayed current than are trying to go back and move the needle by doing an assignment from 2 months ago that's barely going to affect you. Stay current on what is happening now so that your quizzes are better, because the quizzes have more weight in the grades. Okay? You are not going to improve your grade by doing these 3 missing assignments from the beginning of September. You're going to move the needle, you are going to improve your grade by staying current, by knowing what's going on right now, and doing solid on the quiz on Thursday. We've only got 3 quizzes in the gradebook. That means the one that you take on Thursday will be quarter, 75, 76, 75, 18, 19, 19.5%. It'll be about 19.5% of your current grade after it goes in. Because there's not many quizzes in the gradebook. Man, if only you had open notes, open everything, and did a review right before you did it that looked just like it.
I wish.
Right? So, going back and worrying about old stuff, while it'll help you understand content, is not going to be the thing that changes what you're seeing on campus. You want to change your grade, participate in class, wander down during Spartan time, ask some questions. You have White 4 class. Stay after for 10 minutes and do a problem or 2 with me. Use Remind, ask questions. And then on Thursday, when we review right before the quiz, lock it in. Don't worry about entertaining your neighbor. Don't worry about making googly eyes with the cute kid over there. Okay? Focus. So, quiz on Thursday. That also means you're going to need to turn everything in on Thursday. I'm not going to go back and look at stuff from weeks 1 and 2, or from units 1 and 2. I'm going to look at the stuff from the last 5 days. If you have stuff from before that, you better come have a conversation with me. Okay? You should have everything from 2-4 going forward. That's what I'm looking at. As long as you turn that stuff in, as long as you've been doing what you're supposed to, you should be fine. Your quiz is going to cover 2-8, 2-7, 2 days of 2-6, so expect at least 1, likely 2 problems about unit conversion. And then our literal equations. Remember our formula stuff, rearrange the letter soup? That's what's going to be on the quiz. Okay? So, make sure you have that stuff from 2-5 forward. I will go back and look at some 2-4 stuff if you finally did it. But 2-5 forward is what needs to be done and handed in on Thursday. Cool? Okay. We felt okay about the proportion stuff, right? Jesus fish. Cross, multiply, and divide. Right? So, we use that to compare things that are similar. Similar means they got the same shape. They got the same characteristics, but one of them is mini-me. Figure it out. You got a sailboat and a model of the boat. How long is the model of the boat? Argue with your neighbors, figure it out. I sure hope you're not going to leave this mess on my table.
That was all.
Okay? Figure it out. How long is the boat? Argue with your neighbors. Most of you seem to be getting to this pretty quick. Because if I take this and divide it by 3, then if it's to scale, I should also be able to divide by 3, right? Have any of you ever played around with models or even looked at them? Like, they have specific scales of models. They'll say like a 1/64th scale car model or a plane or whatever. The scale of them is this ratio. If I divide by 3, then that means this is a 3x scale. It is 3 times as large. These are called similar figures because they're the exact same shape. I make it all perfect. Like, if you, maybe I think about this more because my grandpa's really into cars and my kids love playing with the little, they're kind of fancier cars. Like, it's not like Hot Wheels, you can chuck it at a wall and it's still going to survive for another couple decades. But like, they're a little bit nicer. You open the little doors on them, and they got you can see the steering wheel inside the car, that kind of stuff. Okay, they just like those because they jam Play-Doh in there, and then I have to clean it out. But in those, you see all of the features, right? And if I didn't have it to scale, you would be able to tell. Have you ever looked at a toy and wondered, why is that steering wheel about the size of a hula hoop comparatively? Why is the door on that so tiny? Why are the tires on there? Oh wait, it's from South Dakota. Okay? Like, you have this proportionality to you. Okay? Y'all teenagers, you're all thoroughly interested in one another. Yeah, we're going down that road. Have you ever heard about something called the golden ratio? Do you know that what constitutes an attractive face is literally symmetry and proportionality? When you look at a person, you're like, eh. Do you know that the human eye can see a difference of like 2 millimeters in just the placement of your eyes? The difference of one nostril is a little bit bigger than the other. Have you ever seen someone smile and their teeth are just a little, Just a little bit. Perfectly good looking person, but that little, it's the first thing that your eyes zero in on. It's what our brains are conditioned to do. And then you throw in like media bias and unreal expectations and all that. We look for symmetry. We look for proportionality. What if you saw me come in one day and I just had my left arm was just like jacked, like SpongeBob ripping out of the shirt, jacked. Looked like Dr. Jekyll, Mr. Hyde kind of stuff, right? It would be a little obvious.
Little weird.
Like, A, are you the guy from that arm wrestling competition Super Bowl commercial? Or B, how hairy are your knuckles? Okay? Depends on the person, and well, we'll tell you when you're older. Okay? Things that are similar are things that have the exact same shape. And if they have the same shape, then they're going to have the same ratio. I know that if this is 3 times bigger than that, then so is that. And we got to get used to the notation of them. Have you ever seen, I know you've seen it, do you remember seeing this?
Yeah, I remember that from last year.
Okay.
All the time.
This says triangle A, B, C, meaning these are the vertices of the triangle. This is triangle FGH. These are the vertices of the triangle. And this right here means is similar to. Means they're not going to be the same. Does anyone remember what the word for they are the same? Not equal to. Getting,
Equal.
what do you think? There it is, congruent.
Oh.
Congruent. Okay, when y'all head on to geometry, you're going to be playing an alphabet soup with this kind of stuff. Okay, lots of figures, and there's a whole unit devoted to similarity in triangles. Okay, we also got to get used to some of this notation. If I say that things are similar, if I have similar geometric figures, you know what? And I'm going to say if I have triangle similar to triangle, it means all the angles, not all the angles, the corresponding angles are congruent. Okay, maybe we need to write that symbol down. Do we remember that? This is congruent. Congruent is fancy geometry speak for have the same measure. So, y'all tell that Siri chick to just back off, okay? Okay, so I want to get some different statements up here so you see the difference between them. If I say, right here, you just look at them. Those two are the same, right? Or the same angle. Not the same side length, same angle. There's two statements I can make. I can say that angle A is congruent to angle F, but I can say the measure of angle A equals the measure of angle F. Okay? Congruent literally means has the same measure. If I use an equals sign, then I'm talking about a measurement number. so I have to include measure of angle in front of it. It's a little picky thing, but it's an important thing later on when you get to geometry proofs. Okay? So I'm just trying to go through some of the terminology, some of the symbols, because I don't know who remembers what. But if I have two triangles that are similar, their corresponding angles are congruent. What does the word corresponding mean? You've all taken standardized tests forever. Fill in the bubble that corresponds to your answer.
Like goes with.
They match together, right? So give me an example of corresponding angles. A and F. They're in the same spot, right? Like if I said, I'm going to get hit with the shrink ray, and I'm going to turn into Mini-Me. My head should not be this size anymore, right? Head corresponds with head. My head should not be the size of my foot right now. Why would I correspond those two things? I put the things together that go together. I would put B with G. I would put C with H because they go together. So if the angles go together, then their corresponding sides will too. 10 matches with 15. 12 matches with 18. Would you agree with that statement? So just like our word problem from the other day, I'm going to say little triangle right side is to little triangle bottom. That's a 12. Or we'll say base because some people might take it the wrong way. Big triangle right side to big triangle base. I have to compare the same thing with the same thing. Right side with base, right side with base. Could I have also written 10 is to 18 as 15 is to 12?
That makes sense.
I don't know. It's just like different.
It's different so you can't. What do you mean different?
Like one belongs to a bigger triangle and the other belongs to a smaller, so it seems like it doesn't fit.
Okay, if we're comparing body proportionality, can I say Dominic's foot compared to Killian's hand?
No.
Like, they're different limbs on different people. Why would I compare those? It doesn't make sense, right? Another way to check it. How do I know that this is actually proportional? We did it just last time. Cross products. Grab a calculator. What's 15 by 12? Incorrect. Remember? 180. What is 10 times 18? 180. If I'm doing this correctly, then my cross products should be the same because they are proportional to each other. I should also be able to reduce them. 10 over 12 reduces to 5 over 6. 15 over 18, divide both of them by 3, is 5 over 6. They are proportional. Put it back. There's a difference between I'm using this to occupy my physical senses so that I can focus versus I'm just a putz and I'm screwing around. Bad, Ashton. So if I check this, are the cross products the same?
No.
No. So you got to be careful about that. When I'm labeling these things geometrically, look down here, they tell us how to write them. Do y'all remember that a segment is written with the letters? They're called the endpoints. This goes from G to H, so I literally just write GH. Now, if I say GH, that means the segment GH. But if I say GH with a line above it, that's the measure. Okay? So I know this is a lot of, you've seen it before, but boy, has it been a long time. If I say angle A versus, this is actually the name of the angle. This is the measure of it. You've got to get used to that notation. If I say an equal sign with that squiggle above it, this means congruent. Congruent means has the same measure. Versus equals means, well, equals. Equivalent numbers or values. Versus I have just the squiggle, it means similar to. So you saw all this before, right? Might be a little rusty on it, but we've seen it. Okay? We have to match corresponding angles. We have to match corresponding sides. You got to match the same thing to the same thing. That opening problem, I'm not going to match the height of the boat's sail with the length of the other boat's keel. Okay? I'm not going to do it. How does it come into play? Exactly the way we did before. It tells me they're similar. I can't start the problem if I don't know they're similar. Once they're similar, I know all of this stuff matches with that stuff, and they're proportional. They asked, what is DE? What is DE? So I ask, what does DE match with? AB, right? DE matches to AB. I just said little left to big left. Okay? What's something that you have on both of them? Okay, now you said BC and EF. What way should I write it? I said little triangle to big triangle here. So I better say little triangle to big triangle. Can I fill those in with numbers? Yeah. Now you don't have to put this part down. I'm writing it because I want you to understand that. It's kind of important for the rest of your high school career. But then just match. What's DE? Oh. What's AB? 10. What's EF? 12. What's BC? 16. Oh, hey, look, it's a proportion. We just got done doing this, and we were all really good at it because it's easy. Cross, multiply, and divide. Or, Jesus fish, multiply the two that line up, divide by the one that doesn't. What is 12 times 10? Divided by 16.
75.
Okay, you know what? I will take 7.5 because it is a terminating decimal.
7.5.
I know it's on there, but it's a terminating decimal, which is why. So I'm going to say that DE is 7.5 or 15 halves. And that's it. You match the things that match. Cross, multiply, and solve. Ta-da! That's proportionality. We cool?
Yes, I like it.
All right. Hey, you. Then, what is AC? So now they want you to do the same thing, but what's that? Set it up. Make sure you compare the correct thing to the correct thing. If you're saying left side to left side, big to small, then you better say base to base, big to small. Okay. Suppose it would help if I didn't have a random box on top of a number.
Which ones do you want to split? A, C?
Trick I always used to show my geometry kids, it literally puts it together for you if you can visually represent right side over base equals right side over base. Because now it sets it up for you. It's right there on the figure itself. Now I set it up this way. Doesn't mean you have to. Who said right side to right side equals base to base? Like that. Couple of you? Okay. You still get the same thing, right? When you cross multiply, when you set up Jesus fish, you still got 16 and 18 divided by 12. You still have 16 and 18 divided by 12. If you set it up correctly, so long as I am comparing same thing to same thing, same thing to same thing, you're good. Okay? So what is it? 20 or 24? 24. Another thing to note about this, units. Especially when you get into geometry, units are very important. Right now, Sailor, what are my units? Exactly, putting away. Next time Mom Bear asks me how you doing, should I be saying, I don't know, why don't you check her streaks? Okay. I don't see a unit next to this, right? They don't say inches, they don't say feet, they don't say miles, they don't say meters, nothing. So I'm okay with just saying x equals 24 because they didn't tell me a unit. When you get to geometry, they're not going to be okay with that. They're going to want you to just put a generic unit next to it. Because so it's a thing. I'm not going to make you do it now. I'm just trying to front load you for later. Okay, applying similarity. I don't know how much they show you in middle school. Do you know what parallel lines are?
Yes, they go in the same direction. Remember, because of the two L's.
Train tracks, right? Heading in the same direction, never cross. The sun's rays are parallel. If I've got the happy sun up here, its rays are coming down in parallel lines. And you're going to learn a bunch of stuff about parallel lines and about lines cutting transversals, alternate interior angles, all that kind of stuff later. But what it means is it's going to create a bunch of similar figures, a bunch of triangles. So I can compare same thing with same thing. This is how you measure the height of something. It's called indirect measurement. If I know, how tall is Heath? 5'10"? If I know Heath is 5'10", but I know his shadow is 7 feet long, and then I come over here and I measure the shadow of this tree is like 30 feet long. Couldn't I compare shadow to shadow? His height to height. I can now figure out how tall that tree is based on measuring his shadow. Because similar figures. That's what's happening over here. We've got stick figure Stacy is 5 foot tall with a 3 foot shadow. So I can match that up with a X foot tall building with a 15 foot shadow. Match the same thing with the same thing. Now I did height with shadow, height with shadow. I don't have to set it up that way. I could have said stick figure Stacy's height to the building's height is stick figure Stacy's shadow to the building's shadow. In both cases, look at what I'm multiplying. 5 times 15 divided by 3. 5 times 15 divided by 3. It's just a difference if the fish is swimming along or the fish is dead at the bottom of the tank. Okay? Well, what's 5 by 15?
75.
Divided by 3. 25. There you go. X is 25. 25 feet. Because this time they did tell me what the height was, or what the unit was. Do the same thing. Same thing, but now they're going to talk about what? Flagpole? Pretty common. Match. Same thing with same thing. Okay. If we say 2 pancakes is 1 cup of syrup. Well, I got 6 pancakes. How many cups of syrup am I getting? Okay. As long as you're matching the same things, you're good. Okay. Some dude is 6 foot tall. That's his height. His shadow is 3.5 feet. So if I just said height is to shadow, can I say 17.5 to x? We just said height is to shadow. I can't say shadow is to height because I haven't compared same thing to same thing. You have to say height is to shadow. Multiply the two that line up, divide by the one that doesn't. How much? Because they say in the problem what my unit is, I'm going to make sure to throw my unit on my answer. Well, labels matter, right? Trey, I've got 5.
5 what?
Do you want 5?
5 what?
Do you want 5?
Sure.
Okay, 5 detentions it is. I'll give you 5 detentions. We'll set up with Miss Peterson out in the cabin. You'll be good to go. Okay?
Man.
Grace, I got 6. You want 6? That's a bummer. I had 6 like packages of M&Ms in there that I got at Safeway this morning. I was just gonna like give them to you, and then
I want 6.
bummer. Okay, the label matters, right? The label matters. Think about the real world. Does the label matter? Am I classified as this or am I classified as that? Am I a minor and they can legally pay me below minimum wage because South Dakota? Yes. Am I a waitress who gets tips? Okay, they can pay you $3.25 an hour because now they're including the tips as part of your salary. The label mattered. Are you the hostess or are you the waitress? Are you washing dishes or are you the manager? Because if you're washing dishes, I guarantee you're getting paid hourly versus you're the manager, you got a salary. Okay, the label matters. Wasn't this the class where like a couple of you are all working at the same place, like washing dishes or bussing tables or something? As you goobers? Okay. All right. Scale drawings. Y'all in geography, have you had to do the scale drawing thing yet? Not yet? Okay, good, good. Then, unlike physical science where you had to do the unit analysis stuff before you got to here, at least we'll get to this before you hit it in geography. Have you ever looked at a map and they got that little box in the corner and it says like 2 inches is a mile or something? Right next to the legend, like these are highways, these are interstates, and so on. Okay, that legend tells you so that you can literally grab a ruler and I can say, thwomp. All right, so that's like 3.5 centimeters. Use my ratio over here, and now that I know how many 100 kilometers it is between Berlin and Paris. Okay? That's where this is going to come into play. You will do this in geography. So, see how it's done. It's pretty easy. What is the actual distance from Jacksonville to Orlando? Check out the scale. 1 inch is 110 miles. Take a look at your paper. From Jacksonville to Orlando. Y'all know how to read a ruler? What is that?
That's about an inch and a half.
Is it?
1.4.
I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Each of those tick marks is a 16th. 4/16. That's 1 1/4. So if I have 1 1/4 inches, I'll say, well, 1 1/4 inches is to, I don't know how many miles, as, what do I say next? Got to say it in the right order. 1 inch is 110 miles. I have to compare same thing to same thing. Now, you all remember from probably elementary and middle school, we don't actually work in mixed numbers. That's not how the real world works. We always turn the mixed number into improper fractions. Do you remember how to turn 1 1/4 into a improper fraction?
It's something about, no, wait, that's 4 times 1 has to be
I have 4 whole groups, or 1 whole group of 4, plus 1 left over. So I have 5/4. Now I'm betting most of you probably aren't going to talk about how many quarters of a mile you're talking about. Not too many GPS apps on a phone are going to work in fractions. So if you wanted to call that 1.25 inches, I'm okay with it. And just like before, multiply the 2 that line up, divide by the 1 that doesn't. What is it? 1.25 times 110 divided by 1 is? Anyone else? Is that actually what you got, or are you just parroting her? Okay. 137.5 miles. Okay. So you have to be able to read the scales. Now, unfortunately, it says the distance is 0.6 inches. I was going to say, like the scale gets blown up by the picture on your notes, but they wrote it right there. Do the same thing, except now you don't have to smack a ruler on the map. They're just going to tell you. From Jacksonville to Gainesville is this many. How far? Use the scale again. Match the same things again. It's not going to happen by osmosis. Well, smacking your forehead into the book, it's not just going to poof into your head like that. Got to write it down. Match. Inches to miles is inches to miles. If they tell me 1 inch is 110 miles, what do I set that up with? Do you know it? Okay.
0.6 inches over x miles.
Inches is to miles as inches is to miles. Compare the same things. 0.6 inches is to, I don't know, miles. As long as you're multiplying these two and dividing by that one, you're fine. What do you get? Okay. Reasoning. I actually do want to go through that. That's a good one, especially for your geography class. If you know the distance between 2 cities is 250 miles, like maybe I know that from here to, what's 250 miles away? Like, is Pier that far away? Is that close enough?
About 260.
I'm just winging it. Let's say this Pier. Let's say it's Pier-ish. Okay? We know it's 250 miles from here to Pier. They're 2 inches apart on the map. Can you find the scale?
Yes.
Remember our unit rates from the other day? This over here said 1 inch is blank miles. So if I know that I have 2 inches and it equals 250 miles, what could I do to turn that into 1 inch is this many miles? Divide by 2. Okay. I turn this into a unit rate. If I've got 250 miles per 2 inches, I reduce it down and turn it into 125 miles to 1 inch. Okay? So it falls back on our unit rates from, 2 days ago. You will do this in geography. Just like there were references in the back of your book that maybe we didn't know about because we're not used to using books. We were talking about this the other day in, what was it, math department got together, we're just chatting about curriculum and all that kind of stuff. Is this the first time that you've had just like a straight up math textbook? Like, I know you had kind of like the consumable workbooks or whatever, but like just here's a book. This is math. When was the last time you had that?
5th grade.
Yeah. But like it wasn't like a textbook, it was more of just like, oh, here's your work problems in this book.
Okay.
Yeah, we got
It's
to
like
keep
kind of
them.
reminding you.
All right.
I used to burn them, that's how I remember. Look at all the papers, there were so many.
Okay. All right. Scale models. That looks kind of weird in alternate colors.
Looks like a love.
All right. Who knows their color wheel? What is opposite of blue? Red.
I see it better.
Okay. It's a giant model of a heart.
I'm thinking the other one is more alien.
Anyone ever been to like one of the, like a museum science center or something? I think the nearest ones are probably like Denver and Minneapolis. No? Okay. There's the Science Center in Minneapolis. It's not too far from the Mall of America. If you ever do one of those, hey, we're going to go on a vacation for a weekend, but we can't afford to go to Costa Rica because, we're not rich, then go there, do the science thing. And they got all these just bonkers displays, and you can walk inside the ventricles of a heart. You can, they got the big shaker tables where you can make your own flash flood and watch erosion happen. Like, there's like air compression machines that blast you in the face and then you have to look at a thing and it messes with your eyes. Like, there's all kinds of cool stuff there. So it's worth it. Like, you might actually learn something. But yes, because science. So I'm going to go back to that though because it hurts my eyeballs. Maybe it's the blue dudes from Avatar. I heard they're finally coming out with the sequel for it. Or it's a really big Smurf. Or it's a normal sized Smurf and Killian.
Yeah. Oh. Yeah.
Shade! So, a giant model heart is shown. The heart is the ideal size for a person who's 170 feet tall.
Oh my gosh.
So it's like King Kong's heart. Okay?
Oh my god.
About what size would you expect the heart of a man who is 6 foot tall to be? Don't you want to, depends whether they're the Grinch or not, right? Match the correct things. If we're saying that the model, that's there. The model is 14 feet. And what does the model match with? The model's heart matches with what? Okay. Could I say with the real dude's heart?
Yup.
Do you normally do a real dude's heart in feet?
Yeah.
My heart is 3 feet wide. Wah, 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 wah. Doesn't make sense, right? Probably inches. Okay. So maybe I need to mess with my units just like the word problem that we had trouble with. What I'm going to do is I'll compare 14 feet with 170 feet. I'm going to compare the size of the model heart to the size of King Kong. Because now I should be able to say a person's heart to the height of the person, right? Now we just said we didn't want to be in 6 feet because then the heart size would be in feet. Can I change 6 feet into something else? Inches. How many inches in a foot? Multiply or divide? Multiply. 6 feet is how many inches?
64.
So here's the deal. When I cross multiply, I'm going to have inches, feet, inches, feet. It'll still match because I'll have the same units on the cross products. If I said feet to feet, I can do inches to inches. This is just to avoid saying that your heart is 0.48 feet wide. Most people aren't going to say that. Then cross multiply and divide, Jesus fish. Take 14 by 72 times, and then divide by 170. What do you get?
599.
Ruh-roh. It's some decimal, right?
It is 504 over 85.
504 over 85 as a fraction. Most people are, if I say my heart is 504 over 85 inches wide, or sorry, tall, it sounds weird. So grab the calculator and turn that into a decimal. Say approximately what? 9.3?
Yes, 93.
The heart is about 5.93 inches tall. Yeah? It's a big honking chunk of muscle. It's supposed to keep you running for a couple decades. Well, depends on the person, right?
I'm planning to live past 37. That's my goal.
Same. So, same thing. If the building is this, and this is the scale, go get them. You might have to monkey with your units again.
Scale. Model of building. 6 inches.
Make sure you match. Same thing with same thing. Watch your units. Probably be a good idea to line up inches with inches, feet with feet. You can, because you said inches to inches, feet to feet. So 1 to 50 is 6 to what? You're good. You have to match the same thing. If I say inches is to inches as feet is to feet, I could also say inches is to feet as inches is to feet. Match the same things.
Yeah, I did that.
Okay. If 3 breakfast burritos equals 2 trips to the bathroom, then what happens if you eat 9 breakfast burritos? Okay?
That'll be a lot of trips to the bathroom.
So,
Unless you skip the trips to the bathroom.
I mean, they make adult diapers if you just want to rock it in class. I mean, have fun, Ashton. Legit, that is a thing. Like, some people can't actually control their bodily functions because of various disabilities. I worked with a kid years ago who had encapresis. Like, he actually would just drop a nugget every now and then. He had no control over it. It's just what his body did.
That's okay.
Yeah. A turd.
Oh. Did you have to wear diapers, guys?
Yeah. Like, it's nothing to make fun of. Like, it's a disability. Your body medically will just do this. You don't have control over that. Okay? Now, if Ashton's just being lazy and wants to take a dump in it because he's mowing down too many Pop-Tarts and he's far too engaged by the colors on the board, well, then that's different. Okay? Kind of like have you seen the Stadium, buddy?
What?
If you don't want to miss anything at the game, it's literally like a catheter going to a bag that you strap on your leg so that you don't miss any of the game. Yes!
See, that's why I need extra.
And if you're in Chicago or Green Bay, you use that to keep your leg warm.
Yeah, because like you drink the Sprite, you have to go and then you down the Sprite.
If I say that the model is 6 inches tall, and I know that the scale of the model is 1 inch to 50 feet, I can find out how many feet tall my model is. Now, that's the way I set it up. I said inches of the model to feet of the actual building compared to inches to feet of my scale. Cross multiply and solve. 6 times 50, 300 feet. Alternatively, could I have said 6 inches of the model is to 1 inch of the scale, as X feet of the building is to 50 feet of the scale?
That's what I did.
When you cross multiply, look at what is on the cross products. Aren't you going to have inches times feet equals inches times feet? Both cases, it's inches times feet. So if I have inches feet on both sides, I'm fine. Okay. I forgot to put something there.
That's all right.
Y'all get it?
Yeah.
Cool, we're done. Hey, don't get too loud though. Y'all hurt my head.